I've just recently arrived from Japan, where I make my home now. So please forgive me if I'm a little jet lagged. But I'll try to share information you might like. I'm originally an American, and I do live now in Japan. And in Japan, I operate what I believe is the largest electric vehicle race team in the world. It's definitely the largest in Japan, and possibly the world. What I'd like to share is what I've learned about Agile hardware. I've had a chance to work with Saab on the Gripen, and then some of the rainforest projects in Stockholm and Linköping. Then other European larger companies as well, like Bosch and Bose and Mercedes-Benz and BMW and Adaptive. And then in the United States and in Japan, I work with Toyota and Nissan and Honda, and some of the aviation as well. In the United States, I worked with Bill Gates on the same team. I was a Scrum Master on a team with Bill. And Bill started every meeting with, how much of this can we do in parallel? That's very different than in Japan, where the meetings start out with, what's our one-year budget plan? A very different mindset. And Microsoft is a much larger company than most of the companies that want a longer planning horizon. Then I consulted to Amazon when Jeff Bezos was still the active CEO, and I consulted to Blue Origin as well, which, congratulations, Blue Origin, for landing their second reusable rocket booster on a drone ship in the ocean. Just fantastic science achievement. And at that time, Jeff Bezos restricted team size to keep the teams more agile, to give them more autonomy. And he used the 2-pizza rule. Never have a meeting of any type where more than 2 pizzas couldn't feed the entire group. By keeping the meeting small, decisions were able to be made quickly with the information that was available at the time. Then I consulted to Tesla since 2010. And I set up Agile training in Tesla in 2016. And I did join Tesla as a full-time employee in 2020. And Elon was, well, you can finish that with any word you want. He was very determined to move quickly, even more than I thought Bezos or Gates were. Of course, he would do parallel execution like Bill Gates. And of course, he would keep meetings small like Jeff Bezos. But he did much, much more to try to innovate even faster than Microsoft or Amazon had. And Elon would say all the time, and through emails to all staff, pace of innovation is the only thing that matters in the long run. More important than predictability, more important than budgeting, more important than eliminating waste. It was, how quickly are we innovating? Before that, in 2006, I founded a car company, my own car company called Wikispeed. And I started building cars with Agile methods at that time in the United States. Each Thursday, we would draw a new car in CAD, a 3D model of a car, each Thursday morning. Then a big machine would cut the car out of foam, and it took about an hour to make a car-sized piece of foam that looked like the 3D drawing. Then each Thursday night, we would wrap the car in carbon fiber and let the epoxy harden overnight, let it cure overnight. Then Friday, we would go to car shows and try to attract customers. We would track how many interview requests we received to judge how attractive the new car design might be. Inside the car, we had reusable modules. They were aluminum boxes. And those boxes held all the required parts of the car. Some we bought, some we built, some we started by buying and then replaced with components we built. Each Thursday, we would improve each module and build a new car. And each Monday, we would complete all government testing for a new car. Now that's unusual. Most car companies go through required government testing every 2 to 7 years, depending on the model cycle. But we did it each week. Well, how? It's so expensive and it takes so long. If we booked the time, if we scheduled the time every Monday in advance, it was always available for us. We set up a rhythm, like Scrum would have a sprint rhythm. We set up a rhythm every Monday with the government testing labs. And we didn't use a consulting company to then schedule testing for us. We directly scheduled with the test labs, with the test centers. That actually made it very cheap. It made it very cheap and very predictable. And we didn't have to tell the labs in advance what we were going to bring. They got used to it. Every Monday we would bring something. That let us freely design each sprint. And that's very unusual in regulated industries like cars or aircraft or medical devices. We would crash test or simulate crash testing every week. Again, scheduling the time with the labs in advance and then also running simulations. And every week we would produce a different design, a new design from feedback from the week before. And that set 4 world records. And some people say that's what created Agile hardware, proof that it could happen, even in a regulated industry, cars. And then I went to work at Tesla. And I was told my interview at Tesla was the best interview they ever had. As an engineer who likes innovation, that's one of the highest compliments to me in my life. I was really blown away that a company that competitive would let me in and then even compliment me. I was really, really humbled. What I'd like to share next is what did I learn while I was at Tesla, setting up the Agile program at Tesla, setting up Agile training in Tesla, and then operating in manufacturing, in hardware. The first theme is, why does integration slow most hardware companies down? And what's the structure that creates waiting? Why do most of us think 2 years is normal for a hardware iteration, or even 7 years for something as complex as a car, or even longer for an airplane or a rocket, when SpaceX legally flies new rockets every month? And Tesla changes hardware in some of the cars as fast as every 45 minutes, and then legally sells them all around the world. So why? How? Why is it quick? What I'd like to share with you today is speed is determined by design. It's not capability. It's not that all the super talented engineers went to work for one company. It's that the design creates speed. It's the structure. Most companies have a structure that prevents speed from increasing. As adjustments increase, waiting time increases. We wait for decisions. We wait for checks. We wait for approvals. We wait for other departments to finish. The slowness of an organization, I think, is made up not of working time, but of accumulated time spent stopped. In hardware and software, the approved process is usually linear. We have optimizations of departments, but then we have an approval workflow, an approved way of working, and that has waiting for upstream processes and cross-functional coordination, and finally, integration. Most of the Agile scaling that most of us get to use doesn't change this structure. At Tesla, the value of Tesla is not that it builds cars. It turned cars into software-centered products. However, that too is not Tesla's ultimate goal. Tesla is designing a large system centered on energy and AI and software. Cars are part of that platform. Tesla is a company designing the infrastructure of the future rather than just a car maker. And we can detect it when we look at the corporate value. Numbers fluctuate by fiscal year, but as a rough comparison, Tesla is a smaller company in terms of units sold and revenue than established automotive manufacturers. However, when we look at the company's value, the corporate value, the picture is completely different. Despite having a relatively low sales volume, Tesla is evaluated as one of the world's largest companies by corporate value. In other words, the market views Tesla not merely as an automaker, but as a different kind of company altogether. And the way the cars are made is different. In conventional cars, the features are defined in advance and they're fixed when the car is sold. And repairs are conducted at dealerships, and the cars are described as finished products. A Tesla is thought of in the company like a smartphone. The apps you install determine its user experience, and that will include apps that no one has thought of yet. Teslas are built to be defined by their software updates. So new features are added after sale, and the car evolves with data. Tesla cars don't end at delivery, but evolve through software updates. The speed comes in 6 ways. The first is a 10,000-year goal. Toyota has a 500-year goal, and that has been inspiring engineers for decades. Tesla has a 10,000-year goal, which is accelerating the world's transition to sustainable prosperity. These are long-term objectives that define business growth and success, and all Elon Musk's companies have 10,000-year goals. Each 10,000-year goal has a KPI under it, a key performance indicator or a key progress indicator. What can we do right now to move towards that future? The parent KPI, this is the indicator that contributes the most to the 10,000-year goal and can be improved within 24 hours. Under that are child KPIs. Those are experiments for improving the parent KPI. Why is this important? So that even teams driven by short-term KPIs don't lose sight of what matters and to find meaning in the work, to unlock engineering excitement and long-term creativity. And it's our steady guidepost, our North Star. At Tesla, the progress indicators for each module currently in production are displayed in real time. And Elon checks those KPIs once or more every day. A frequently asked question is, can Agile development, which is optimized for specific customers, scale to a global company? Also, what should be standardized through a top-down approach to enable this scaling? Here's what I think I've learned. Agile is not about optimizing for individual customers, it's about learning. Tesla does not tailor its products to specific customers. Instead, it learns from all of them and evolves the entire system. That's why it doesn't settle for local optimization. It scales globally. The only thing we define top-down is the vision. Everything else is left up to the learning process. This module circled in yellow is the center display, the center screen. This module is shared across most Tesla products. The board of metrics, which at Tesla we just called the board, but when I introduced it to Toyota and Honda and Nissan, I did start calling it the justice board. Please forgive me, please forgive me, please forgive me. I learned it at Tesla, but it had no name. Please forgive me. It shows the most important KPIs for this module right now. How much it costs to make one today. The weight of each screen today. The electricity each screen uses today. These numbers are improving a little bit every day, not every 2.5 to 7 years, like in a traditional company. These numbers are measured automatically by robots in the factory. Each center screen is weighed by a robot as it is built. Every screen is tested, and the amount of electricity used during that test is measured. The estimated cost per screen is calculated in real time. Employees use this data to choose what to do next. It's our job as any employee to look at this data and think, which module should I try to improve today? Real time. At Tesla, how do they make real-time decisions? The vehicle itself is constantly sending data, and all factory processes are digitized. It's software-controlled robots and then humans following instructions displayed on monitors. The production, the product, and the software are not separated. They're not siloed. The KPIs are constantly visualized on dashboards. Well, why is that possible? Toyota is still using paper in the factories, so why is this possible? From the beginning, sensors and software are created to collect the data needed to make better decisions. Real time is not about technology, it's about using just a little technology to make decisions quickly. Well, why real time? Being able to make decisions in real time means that changes also need to be implemented immediately. In conventional cars, when we try to change a function, we have a cascade of predefined mandatory processes. Maybe we can apply or tailor some of the processes, but we have a defined workflow to follow, such as parts changes, coordination between departments, and coordination with suppliers, and required retesting. Because Tesla implements many functions as software, they can be delivered immediately as updates. The mechanism for making changes is different. In traditional cars, a function equals a component. A change is department coordination, supplier coordination, retesting. It's like a repair. Making a change is like conducting a repair to the product. In Tesla, a function is often software, and a change is an over-the-air update, and a change is an update, like updating an app on your phone. Different decisions, different future. The real-time data and speed of decision-making are not the end in themselves. The fundamental difference is the criteria used to make those decisions. Many companies base their decisions on short-term optimization, such as this quarter's profits or cost reduction. As a result, they stop at minor improvements. Tesla bases its decisions on what is right in the long term and what is necessary for the future. That is why it can make decisions that transform the structure of the company and of the cars, rather than just addressing individual parts. In a typical company, this quarter's profit, cost reduction, and optimizing existing operations are the goals, the executive goals. And so the executives are encouraged to make small improvements and then stop. In Tesla, what is right in the long term and what is necessary for the future, including changing the structure, are encouraged every day. Step 2, they do build their own AI. Cars learn on their own. At Tesla, we used camera footage from cars around the world to learn AI driving. The cars around the world send data, and the AI learns real-world driving. The human driving itself is the training data. But the AI is not just for driving. AI isn't just about improving the accuracy of the autonomous driving. The same thing is happening inside the factories. Defects are detected automatically. Anomalies are identified before they occur, and production bottlenecks become visible in real time. In other words, we're shifting from a system that reacts to problems to one that prevents them from arising in the first place. With cameras, we conduct visual inspection during the manufacturing process and the design process. Scratches, misalignment detection. With sensors, we detect anomalies. We attempt to anticipate before failures occur. And process data, as people are writing software, as people are drawing CAD, as people are talking to suppliers, it's all recorded and fed to AI. That helps us identify bottlenecks in design, in procurement, in finance, in redesign, in testing. Cars and factories alike are learning the same way. The real world is becoming a learning system. At Tesla, not only cars, but factories and development process are all treated as data. Cars generate driving data. Factories generate production data, and development continuously produces improvement data. Everything that happens in the real world becomes data for learning. This means the environment for AI to learn is not being created afterward, but is designed from the very beginning on the assumption of learning. The cars create driving data, the factory creates production data, and development creates improvement data, so everything becomes data. Why is that possible? All data is connected, it's not separated. Cars, factories, and development not only share data, the combined data is continuously analyzed, so improvements are made to the whole, not only parts. Because changes can be made in software, these improvements are implemented immediately. Tesla is not optimizing each part separately, it's continuously learning as a whole. Data is connected across the entire system, and systems can be modified by the software, and improvements are implemented immediately. Learning across the entire system, not only in departments or phases. Well, what is proprietary AI? A proprietary AI does not require writing your own software. It is better if you do, but it's not required. What's more important is how your system uses your data. Your system learns from your own company's data and is improved with your company's environment and becomes more accurate the more you continue to use it. AI is not something we create once, but it's an ongoing initiative. Your proprietary AI is trained on your company's data, and it's improved within your own environment, so the accuracy continuously improves. Step 3, modularity. This is one of the pieces I helped grow at Tesla. Most of the other pieces I learned while I was working there. The first step to take a complex product and execute it quickly is to split it into pieces. We call this modularity. These pieces are changed independently of each other. Modules are planned, designed, built, and tested in any order or at the same time. Modularization is a design that doesn't wait. In a traditional structure, we need to wait for other teams to finish. In contrast, a modular structure can be completed within the team, allowing us to move forward without waiting. The difference becomes a difference in speed. In a traditional structure, we break work down by function and we rely on other teams and we leave final integration for the end. We wait on others. In a modular structure, we have functionality centralized in our module. It's self-contained within our team. And then we have continuous integration to other teams. We move forward without waiting. The left diagram shows a traditional structure. Systems are separated by function, and each is intricately connected. Changing one area affects others and requires adjustments. The right shows a modular structure. Functions are organized into cohesive units and designed to operate as independently as possible. As a result, changing one part has minimal impact on others, and work can proceed smoothly. The difference determines whether development comes to a halt or continues without interruption. This is Tesla's semi-truck, a heavy-duty electric vehicle. The Semi reuses the interior package of the Model 3 and Model Y. This includes the interior electronics, heating, cooling, CPU, and display, the parts shown in red. The driver display and computer is improved every day, and the rest of the truck does not have to change. There's no ripple effect. The early version of Tesla's Semi uses 4 of the Tesla Model S battery packs. Now they use mega packs that are also used to provide stable power to AI data centers. The battery pack production line is upgraded daily, so every truck is potentially unique. The Tesla Semi uses the same seats as the Tesla Model 3 and Model Y. The seat can be changed any time to be a gram lighter, less expensive to build, and more comfortable. No meetings are needed between module teams. New versions of each part are installed without needing coordination between teams. Okay, well, how do we do maintenance? How can we maintain something when all the new cars are potentially unique? There could be thousands of versions. Modules and interfaces make this manageable. Tesla technicians around the world are trained on interfaces, not every module and their hundreds of versions. For example, Tesla Analytics detect a problem or a customer request service from the app on their mobile phone. A Tesla service car travels to the customer car location and swaps the defective module as fast as possible wherever the car is parked. Defective modules are brought back to the factory for regression testing, and defective modules are rebuilt or recycled. In 2006, I published Justice's Law. We take the module count and restructure the company into that number of independent business units or sub-companies for maximum parallel execution, for maximum speed. Waiting is further reduced by creating full-stack teams that do not wait on central services such as procurement, embedded software, mechanical engineering, etc. And we try to match our teams to the modules. On the left, teams are organized by skill set. Since they are divided into UI, control, and testing teams, they must wait for other teams to finish their work. The right side shows teams organized by deliverable. Teams are formed around functional units, such as navigation and autonomous driving, so all necessary skills are available within the team. As a result, each team can complete its work independently. It is a structure where work can be completed within a single module. This is why there is no need to wait. Now, we as Agile people have been talking about this more than 26 years now, but it's still so rare. When I visit high-tech companies in China, in Vietnam, in Japan, in Europe, in the United States, still they're separated by skill. It's easier to manage a team with just one skill, a UI team, or a back-end team, or a QA team. It is easier to manage. It takes more energy and effort to manage a cross-functional team, like a navigation team. And humans seek less effort. We're very lean as a species. It's really a beautiful thing. But I think this is necessary for fast speed. The result is parallel execution. By assigning cross-functional teams to each module, development can proceed simultaneously rather than sequentially. Traditionally, since work proceeds sequentially through phases, we have to wait until the previous phase is complete. Instead, by dividing the work, we can proceed simultaneously without waiting. Each team develops independently while verifying quality through automated testing and integration. This is what makes the difference in speed. Frequently asked question: who decides the interfaces? I recommend design as a team, not as an individual, and don't decide everything up front. evolve through experiments. It is impossible to plan product architecture and organizational structure in advance. No one knows how. Not Amazon, not Microsoft, not Google, not SpaceX, not Tesla, not Naver, not any of the tech companies that are in China. No one knows how to plan a product architecture and organizational structure in advance. The only solution seems to be we guess, and we complete a product release, and then we restructure. Now, most executives are afraid of the idea of declaring a restructuring and then declaring a restructuring again. It makes it look like they failed the first time. But this is the only way that works. Step 4 of 6, automate testing. Modules are tested individually in what's called factory mode. And maybe you can see it, it says it across the screen here, factory mode. And they're tested again as soon as they are connected to the car. Here, the steering column, the dashboard, and the interior package are testing each other as the car is assembled. The engineers do not run tests on the car. The car tests itself. These tests never stop running. They report precious analysis of how the car is being used and its health during the entire life of the car. In the hardware world, an iteration review is not just a functional check. It means the product is fully tested, it is certified, it is in production. At Tesla, every vehicle automatically passes non-destructive compliance tests, certification tests, and quality checks. Destructive tests are simulated. This is called factory mode. Vehicles are verified as they are assembled. The ultimate goal of integration should be to automate the integration process as much as possible. Step 5, iteration. Here is the heating and cooling module that is shared across all Tesla products. This module used to be big and complex, heavy and expensive. Before, many parts were bought from other companies. This module became simpler and smaller each day. Employees join group work assisted by AI to try to reduce the weight of the heating and cooling system by 1 gram each day. Employees experiment to speed up the manufacturing of this module by 1 second each day. Employees change the design to reduce the cost to manufacture a module by 1 penny every day. This is real Agile, where we design, build, test, and deploy every day. Tesla teams often design, build, test, and deploy in less than 12 hours. Maybe the most difficult step for a traditional company. Tesla is more flat than most of the companies I've worked in or consulted to. The traditional organization is a hierarchical structure. The higher we go, the more decision-making authority there is, and the lower we go, the more we take on execution roles. Therefore, when a decision is needed, it must be escalated upward, and we need to wait for the decision to come back. On the other hand, in recent software organizations, structures are changing to small teams that take responsibility. Teams coordinate via application programming interfaces and other interfaces, and necessary decisions are made close to the team. This is an organizational design that shortens the distance of decision-making. Speed is not achieved by effort. It's born from design. So what would we do in our clients, in our studies, in our own companies? For a lot of companies, it may be difficult to change the organization immediately, but we can start by noticing the current situation. And first, we can start with our own work or whatever team we're in. We can build small, we can get feedback quickly, we can iterate through trial and error, and we can continuously improve. The accumulation of these efforts creates within the team a small speed. Some decisions require leaders from different groups to organize together. When leaders agree, the organization can evolve. So consider these actions. Launch a real-time data project. Divide an existing product into modules. Create in-house cross-functional teams for each module. The accumulation of these efforts creates a great speed. What is right in the long term and what is necessary for the future is probably changing the entire structure. And in most companies, the leadership has been divided by skills. We have a head of QA, and a head of backend, a head of front end, a head of procurement, a head of HR, and they would all need to agree to change the company structure. So of course it's uncommon, of course it's rare. But if they did, we might have a much faster company. Maybe the good news is it looks like in hardware as well, it's the exact same Agile. I use the Scrum Alliance certification system, but all of the certification systems or not seem to apply just as well. If you have experience with Agile coaching or Agile training, it looks like it's exactly the same in hardware. Teams still need to know the exact same rules, roles, artifacts, etc. I do like the current split of having everything you need to know shown to the teams, and then maybe a quarter of a year later, maybe 3 months later, have the reminders, and maybe some advanced practices, but more that it's a reminder. And then maybe 3 months later than that, the professional level. And they become, I hope, reinvigorated and excited and refreshed and refocused. And there's additional content too. Fast companies, I think, are born from fast teams. And fast teams are built by continuing to learn. What changes the future is the accumulation of these small experiments. I'm very grateful. It's my first time here in Örebro, and so far the coffee's great. And so far, people are really friendly. I'd like to know what you think about today's content. We do have Q&A, but also if you use social media at all, I like social media. Maybe some of you do too. Please consider connecting with me on whichever platform you use, whichever platform you like. For me, it's a fun hobby, and I get to stay connected to people, even if I've only met them briefly at a conference. Later this afternoon, after lunch, I'll do a group AI-assisted development workshop. You don't need coding experience. We'll rely on simple AIs to do simple build. And I hope it's a lot of fun. And you do work with whoever happens to be sitting near you, so it should be networking. But even if you're low energy or feeling shy, please still consider coming. I think it will be enjoyable. I hope to see you in the afternoon. Thank you very much.